Hey, Geotrig, lesson 14. This is the last part of it. I'm not exactly sure the exact day, but we're going to actually switch from polar to back to rectangular. So yesterday we had rectangular. We found 4 different versions of a polar point. All lead you to the same place. Today we're going to be taking one of those 4 forms. I don't care. Actually, an infinite amount of forms for the same place. And I will find the direct way to get there using I hat and J hat or X, Y. Now, I gave everybody a copy of these notes yesterday. I did change them up this morning. 3 is changed, and I added an extra problem on the bottom. So, guys, the first thing you need to do, plot the point. Makes sense. Spin it, walk it. So that's what we have to do for number 1. Number 2, you guys still have to form your right triangles. You form your right triangle with the point in space to the origin, and then from your point straight to the x-axis, which means straight down or straight up. Three, label the angle. Now sometimes that's called the reference angle. I'm going to talk about that today because I don't think I've talked about it yet. The radius, and then I would also add in there possibly put your x and y on your triangle. What I mean by x and y, the sides of the triangle that you don't know, but the x goes on the x direction, left to right, and the y will go on the up or down. Yesterday we talked about every single time please use tangent. Today, every single time please use sine and cosine. We're going to be finding missing sides. So therefore, the missing sides are the opposite and adjacent. Those are the only, they are easily found using sine and cosine. And then the last thing we'll do, once you have your x and a y, you will put it into I hat and J hat form. The biggest thing we have to worry about is if I'm going backwards or down, my x's and y's will be negative. If I'm going forwards, they are positive. So make sure you watch your signs. So, let's start with our problems. I took out the extra problem there. We'll bring it back on the next page. Actually, we got to go to the next page. What is a reference angle? That's a good question. I don't know if we talked about this. What if I told you I wanted to go 120 degrees? You guys probably could tell me where 120 degrees is. Somewhere about there? Would you guys agree with that? Yes. Okay, so if this is 120 degrees, what is the angle left over here to get to the x-axis? 60. I think all of us would agree with this. That 60, guys, is what we call the reference angle. So if I had something like 45 degrees, isn't that 45 degrees about there? What's the reference angle to 45 degrees? 45. It's 45. How do I get back to the x-axis? Boom, it's back 45 degrees. Reference angles are always the positive angle to the x-axis. So if I had a negative 220 degrees, we can find the reference angle because we'll graph it. It's a negative angle, so you start going down. That's 180. I go a little bit further, right? I'm here. What is the reference angle? What's the angle right there? It's negative 220 all the way around. What's this piece right there? Joey? 40. It's 40. 40 is the reference angle to negative 220. I do believe, and I'm not 100% sure, did we talk about coterminal angles? No. Okay. Coterminal angles are things like negative 220 and this angle. What's that one? If I start at 0 and I walk the forward position,
140.
140? So 140 and negative 220 are coterminal angles. Coterminal angles terminate in the same spot. Whether I turn forwards, backwards, I rotate. If you guys were to close your eyes and I rotated all the way around, woo, 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 like this, and then I stopped right there, would you be able to tell the difference whether I went 140 degrees, negative 220 degrees, or spun around 300 times? No. If you didn't see me actually turning, you would not know. All you know is that I'm facing the exact same way every single time. Those are called coterminal angles. They differ by 360 degrees. Keep adding or subtracting 360 degrees, I have coterminal angles. So, reference angles, angles that get you back to the x-axis, always positive. Coterminal angles differ by 360. Let's do this. I gave you a nice one for your first problem to do together. Negative 5, negative 237 degrees. Number 1, plot it. Where's negative 237? Which way am I going? Up or down?
Down.
Okay. That's 90. That's 180. I got to go a little bit further, right?
Yeah.
So somewhere about here? Oh, wait. Should I have drawn a solid line?
No.
Why? What's the radius? It's negative 5. I have to travel 5, but it's not forwards, it's backwards. So it's actually a dotted line this way and a solid line backwards, and I will put 5. We talked about yesterday how distances are never negative. The negative just tells me a direction. So when I actually do my walking with the solid line to get me to this point, I have walked 5. Does everybody understand that? Step 2 says, form a right triangle. Go straight to the x-axis. So that way we can start to label this. We got the radius already labeled. Now we have to label the angle and x and y. Here's a cool thing. That's x. This is y, because that's the x direction and that's the y direction. I don't think anybody should argue with that. Now, I got to find theta. That's this guy right here. What is theta?
Reference angle.
It is the reference angle. But I don't know if I have enough information right now, the way it looks, to tell me that angle. But I do know this one. What's this big one? 237 negative. So if that's the case, can I find this one?
Yeah.
What is this angle? 57. And because this angle and this angle are equal, because they're vertical angles, this is also 57. I think that's pretty cool. So guess what? Back in lesson 14, the first day or two, didn't we solve triangles just like this? Using SOHCAHTOA. So, all right, SOHCAHTOA. So we may use it. 57. Negative 237, otherwise. So, here's a cool thing. Step 4, I think it is, says use sine and cosine. So let's use that. Sine of 57. Now, in the last couple hours, people were struggling. because they didn't realize that, hey, yeah, we got 57, we got an angle. They forgot that whole idea that I was in front of the class and I said, okay, everybody point left, go. And I was in the front of the room and I pointed a completely different way than everybody else and got some people to change their mind. But your left is your left, my left is my left. So what's opposite of me, what's to the left of me, is different than all of you. So remember, if I'm at 57, what's opposite of 57? Y. What is adjacent? X. The hypotenuse is always the longest side. So if I say sine of 57, it's the opposite over hypotenuse, which is y over 5. I can solve for y. Multiply both sides by 5. So y equals 5 sine 37. I could take my calculators out. Make sure you're in degree mode.
Yeah, it's 57.
That is a 57, sorry. 5 sine 57 is equal to?
4.2.
4.2. What if I did cosine 57? What's the ratio? Adjacent over hypotenuse. What's adjacent? It's x over 5. Multiply both sides by 5. X equals 5 cosine 57, and that happens to be 2.5? 2.7. 2.7. Guys, we're not done. I found x, I found y. So guess what I'm going to do? I'm going to write them where they belong. If I write 2.7 and 4.2 where they belong, something should look out of place. Those numbers are my distances, but in the large scheme of things in the xy plane, or because we're talking about I hat and j hats, this I hat and j hat field or form, going to the right should be positive, yes? But what happens when I go down? That number should be negative. So therefore, I have to assign the right sign to it. So that when I go to write my answer, 2.7 I hat minus 4.2 j hat. And you have your answer. Okay, I want to give you guys time. Try this one on your own. Be very careful. You turn your angle correctly and then walk out. It is different than the problem we just did. So your answer should not be in the exact same place. We'll come back to this together. Okay, so number one, we got a graph. And again, we're finding some people are making some slight errors in here. People are doing more work than they have to. They're turning the wrong way. 140 degrees is positive. I'm going to turn to 140, which is here, and walk outward. So I'm standing right there. It's not the best looking of lines and stuff, but there I am. I make my triangle to the x-axis. If this is 140, then what is the leftovers needed to get to 180? 40. That's x. This is y. What do we know about x, though? It's going to be negative because I'm going backwards. Now, I just got to do the equations. Sine of 40 equals... Whoops, I forgot to write on here. 7. Y over 7. Cosine of 140 equals x over 7. Do you guys notice that you did the same thing both times, multiplied by the radius? 7, 7, 7, 7. Y equals 7 sine of 40. I make a mistake?
It's cosine of 40.
Oh, yep. There it is. And x equals 7 cosine 40. What's y?
4.5.
4.5. X?
X equals 5.4.
5.4. So I put them on my drawing. 5.4, but it's backwards, so I better make it negative. And 4.5. What is it in I hat and j hat form?
5.4 I hat or j hat.
Careful. It's I.
Oh. What? Oh, negative.
Negative 5.4 I hat plus 4.5 j hat. Boom, and you are done. These go pretty quick once you get them set up. Okay, here we go. Guys, your homework is to do these 4 problems. I want them converted to rectangular, just like we did. Have a great day. These were right, but the wrong signs. Because you're turning yourself to the wrong direction. Our goal is to get to this exact point every time. Sometimes going straight there and walking, or sometimes turning my back to it and then backing up to it.
I don't see it anywhere.
I am checking right now because Ray is also having this same issue. Oh, what the heck?
That's some
How?
I don't know.
This is the list that I used. You're right there.
Weird.
Is something wrong?
Well,
No, on here. Is there something missing? Is that the right email address?
yeah.
There's a whole bunch of people that don't have one. Oh, you know what I did? I think this is the one. When I was doing it, I closed it out.
Oh. So
Okay.
it never shared with me?
Correct.
Okay.
Guys, I think I figured out the problem with some people, more than just 2. Yeah.
He didn't share with me.
I closed the application before it was done working. By accident, so half of you guys did not.
We didn't share, bro. Well, sure.
Hey, look, I was recording more.